Continuing the design of my dual motor drive controller, I'm now at the stage of having placed all of the components on solder paste, and it's time to solder the top layer of the board. This took me, I think, around 11.5 hours, so it does take time to place components manually. The advantage of this is that during the time it took me from sending away the order to GLC PCB, to getting the boards, to actually getting this far, it's been now, I think, 8 days. So it's much quicker, definitely, than ordering assembly from a manufacturer, because, for example, at PCBWay, many of the components have lead times of 7 working days. So it's this is something that I wouldn't do on a larger scale than 3 boards, but to get prototypes working really quickly, I think this is probably the most efficient way to do it. And I've been using this interactive HTML BOM, which has been generated using a plugin for KiCad, which allows me to easily find components based on either the value or the reference, and I can even also hover over components on this picture, and I can see what component it is. So this has been very useful. This has saved me a lot of time. So thank you, Damien, for this tip. This was very good. And I hope that this can also be helpful to anybody else who assembles prototypes themselves, and any maker out there that works with KiCad. This is truly a great plugin. So now that I have all of the components on solder paste, what I learned when putting things on solder paste, so this was my first time actually using a stencil stencil and solder paste to solder the components. I think my general impression is that it has been very good, very quick, very efficient way to apply solder to the pads, and also much healthier as well, because there are no fumes, there is no smoke while placing the components. All I have to do now is just heat it up, and it will melt. And during that time, I can have my fume extractor running, but that's going to be just a very small portion of the time that it took to actually place the components. So I'm very happy with using solder paste. Some of the problems that I've had was that when the stencil is not really sort of always tied to the board, the solder paste can get smudged, and sometimes also you get too much solder paste. But what I've discovered is that it's better actually to have too much solder paste than too little, because putting any extra solder paste on pads that didn't get any solder paste is very difficult compared to just having a little bit too much and then wicking it off once it's been melted, and maybe you get some shorts between pins, but wicking is a lot easier than having to apply extra solder paste. Any other issues that I've had? I think there were a few. I'm just trying to remember the most useful things that I've learned. Yeah, small components do tend to jump and disappear, so it's good to order a little bit larger number of components when ordering the BOM for a number of boards. Doing several boards at the same time was not an issue at all. I think it's been very efficient. Yeah, right. So also placing the same type of component on both the top and the bottom layer was probably not a very good idea, because it would have been easier to to instead have, for example, some components where all of the instances of that component are on the back, and some components maybe would have all of their instances on the front of the PCB. That would have been better, because then I would have been able to just discard the plastic bags that I've had that the components came in, without having to save half of the tape in the plastic bag, or having to pour components back into the plastic bag only to return to them later. So I think it would have simplified things a bit, but if possible, I think even placing all of the components on the front of the board would have been the best solution by far, and not having any components on the back. But that's pretty much it, I think. All of the components have actually all of components besides one. The one that didn't work out was this ESD protection diode here. I actually happened to order a much smaller package of this diode, so I couldn't fit that one. But all of the other components have landed just fine on the pads. The question still remains, though, if all the pins are wired correctly. That's going to be the step after soldering all of the components, when I'm going to start actually testing parts of the PCB. But until then, I think let's just get started. Let's get on with the soldering. I'm going to be using my hot air station for soldering this. I don't have a reflow oven. Maybe I should get a reflow oven, but right now I don't have one, so I'm going to use my soldering station. And I'm just going to remove the nozzle that I have on my soldering iron. And I'm going to keep it like this. So let's see here. So I'm going to have it without the nozzle, and I'm going to move over the PCBs and just heat them up a little bit, and then I'm going to focus on specific parts of each board until the solder melts. I'm currently using 250 degrees Celsius temperature. It's a little bit too little, I think, sometimes. But on the other hand, some components, I've had components that melted at anything higher than that. So it's probably a good choice, even though it takes a little bit longer to get things melted and properly reflowed. Okay, so let's see here. So I'll start with the board that's all the way here to the left of me, and it's to the right on the screen. And I'm going to start heating it up, just getting it a little bit hotter than ambient temperature, and then getting it hotter and hotter until the solder melts. And I think that getting it a little bit hotter actually makes the flux in the solder paste a little bit more runny, so that components stick a bit better before we start reflowing them. Let's see, there is a missing component there. What is that? Oh, that's right. So I've left out some of the resistors, the current sense resistors, because I'm going to be testing the power first, and then I'm going to be soldering on the current sense resistors after I verify that each stage of the power works as I designed it. I think that's the best approach right now. especially when I'm soldering this manually, because you never know if you mess up some little maybe the voltage divider on the regulator, and you get the wrong voltage out of the regulator. That would be very unfortunate. There's a lot of components on this board, so I don't want to burn any components because of some error in the power supply. So that's why I'm going to be enabling each stage of the power supply separately after I've soldered everything. It's getting a bit hotter. I'm going to get some airflow in here. And in terms of the airflow, I'm using very low airflow because I don't want to blow any of the components off the board. What I noticed with solder paste though is that it's progressively harder to blow them off because they actually stick to the solder paste. There's enough solder paste on the pads when using the stencil that they stick a lot better than my experience before when not using a stencil. But I still try to keep the airflow very mild. And preheating also makes sure that if the flux melts a little bit, then the components are less prone to actually fly off if the airflow is too strong. Alright, let's get soldering. I'm going to focus on one area at a time until I see reflow happening. There's a lot of ground in this board, so preheating it is probably the only way to get to make sure that things don't cool down too fast. There's a lot of heat sinking. The paste is not melting just yet because the board is heating up. It's encouraging to see how long it takes to actually start soldering anything here, because that just means that the heat sinking is very good. I could try something else. Let's see if I can get some soldering going on here first. Yeah, it starts melting now. It was a bit easier here. Yeah, now it's starting to reflow. Much harder to get things started on the power driver circuit. Okay, I'm gonna grab my tweezers and I'm just gonna make sure that components land correctly. I can see two of the components actually touching and not soldering them correctly. Yeah. Moving on to the power stage. So this is pretty much the way I'm going to be doing it for all three of the boards. It's not really that much to look at. It's mainly just me making sure that things get soldered correctly. So I'm finding that because some of the components are placed quite close together, I'm having a bit of trouble with components sort of joining together because of the solder paste. So I have to move them with my tweezers a little bit so that they separate again. Right. But this is what I'm going to be doing until I've soldered all the components, and I'll be back when it's time for testing.